We'll stop at the 340 and then rest for maybe 10 minutes. After that, we continue again. So winding for the PM brushless motor, permanent magnet. This one. This. Oh, lagi kena, saya kena copy paste dulu. Aha, okay. So we are talking about the winding for the permanent magnet brushless motor. Okay, so what is the windings we have? Permanent magnet brushless motor can have any even number for the magnet pole. So in a motor, we can have a 2, 4, 6, 8, 10, 12 poles, but we cannot have a ganjil, the so-called not non-even odd number like 1, 3, 5, 7. No, we cannot put a rotor pole like this. And then any number of the stator slot NS with generally is a multiple of the 3 phases lah. Which means if let's say we want to have a stator slot, it can be 3, 6, 9. If let's say it is 3 phase, if let's say 5 phase, it must be 5, 10, 15 like this, multiple of it. Assumption is all slots are filled up by the phase winding. Therefore, number of slot NS always multiple of the number of phases like this. So which means NS equals to K equals to NPH. So K can be 1, can be 2, can be 3. It depends on that. And then yeah, K is integer lah, which means it is a 1, 2, 3 like this. Then each slot can accommodate 2 coil sides within the double layer, or each slot can accommodate 1 coil side in a single layer. 2 coil side, which means one slot we can cut into half. Then single layer, all 1 slot will fill as a 1 coil. Only balance winding are considered. In the motor, we only consider balance winding. So in case of 3-phase motor, the angle displacement must be 120 electrical degree. For example, this is phase A, phase B, phase C. This must be 120 electrical degree, 120 electrical degree, 120 electrical degree. It must be like this between the phase ABC. Coil span. Coil span means distance. Distance of a coil. Just like we put in an engineering term, we call span. A given coil is a wound from one slot to another slot, can have its span, its distance, or we call width, measured in the mechanical degree or electrical degree. For example, in a 15 slot 4 pole PM motor, the coil could be spun from slot number 1 to slot number 4. So coil span can be 3 slots, and then 3 times 360 divided by NS, it is a 72 mechanical degree. This is pure coil span, which means if let's say we slot from slot number 1 to slot number 4, the distance it took is 72 mechanical degree or 144 electrical degree. How to get this value is actually we use mechanical degree equals to, electrical degree equals to mechanical degree times pole pair, which means 72 times pole pair. This one is how many pole? 4 pole. So 4 divided by 2, which means 72 times 2. We will have 144. As a rule of thumb, maximum coil span is equal to the next lower integer level. Next lower integer level after dividing a number of slots by number of poles. Which means if let's say you still remember the basic motor sizing calculation, the first thing we calculate is number of slots per pole, which is number of slots divided by number of poles. Let's say this is a 15 slot for pole. So how much is the value? How much? Calculate that. 15 divided by 4, how much? Give me some value. 3.75. So the next lowest integer level, I think after dividing is equal to the next lowest integer. Lowest integer, is it? Because the lowest integer here should be 4. Next lowest NLI. Maybe 3 is included lah, nah? 3 is the next lowest integer, and then 4, 5, 6 like this. So the lowest one is the 3 lah. So we will choose the maximum correspond of 3. For instance, with an 18 slot and an 8 pole, so we use 18 divided by 8, which is 2.25 lah. Therefore, the preferred correspond will be the maximum correspond of a 2 slot pitch, because the next lowest integer is a 2, 3, 4 like this. The next integer lah. So this is the lowest one. Another example is 18 slot with a 6 pole. So 18 divided by 6 is a 3 slot exactly. So we just use exactly 1 as a 3 slot pitch. So correspond or pitch for the different. Pitch is an angle. Pitch is an angle. Correspond is a distance of a coin. Distance or width of a coin. Different slot per pole ratio, which means number of slot per number of pole ratio. So slot per pole can be 0.75, 1.125, 1.5, because there's a lot of different slot pole number. So for example, as long as this value, the NS divided by NP, lower than or equal than 1.5, we will choose 1. So 0.75, it is lowest or equals than 1.5. So we choose 1. This one also same, lowest or equals to 1.5, we choose 1. Lowest or equals to 1.5, which is the same, right? We also choose 1. But when it's more than 1.5, then we need to choose the NLI, the next lowest integer of the NSPP. So if let's say the NSPP is 2.25, then we choose 2. 3, we choose 3. 3.75, we choose 3. 4.5, we choose 4. This is how we choose it. Slot pitch. Slot pitch is the angle per stator slot. Angle per stator slot. Slot pitch is normally given in mechanical degree or electrical degree. Please remember, for mechanical degree or electrical degree, the conversion is electrical degree equals to mechanical degree times pole pair, where P is a number of pole divided by 2. We call pole pair. Then this electrical degree equals to mechanical degree times pole pair. It has a lot of variables. It can be theta. It can be omega. It depends on which one you want to use it. So for the slot pitch, we usually use theta S, which means the angle per stator slot. We use 360 degree divided by number of stator. So for example, we have an 18 stator slot. So we use 360 divided by 18, then we have a 20 mechanical degree. After that, this 20 mechanical degree times pole pair. Pole pair is a number of pole divided by 2, which is a 6 pole divided by 2. So we have 20 times 3 becomes 60 electrical degree. So one is mechanical degree, one is electrical degree. What's the problem? Yes, Kelvin, please ask.
Sorry, doctor, I think this one discussed before already.
Okay, thank you very much. Or else I'm stupid and just go on.
Yes.
Thank you so much. Okay, so I will stop here. Then I will continue the winding layout. Thank you very much. Where is it? This one I forgot to do. Thank you so much. Since that one already discussed, we directly go to solve on how to design the winding layout. In terms of how to design the winding layout, we need to know what is winding layout first. Winding layout is the things that how we want to place the conductor either in or out. For example, we can slot in here and then go to the back and then come out like this. We also can slot in here and then go the other side and come out like this. But the problem is which one correct. So this one, this is the things that uh, I need to share with you lah. I mean, we need to discuss lah. So we go for the easiest first, which is a 3-slot 2/4 p.m. machine to understand how the calculation first. So first of all, the theory that we need to know, no matter what is that, we need to know that the electrical and the mechanical relationship, it must be times with the pole pair. If let's say we are talking about theta, then it must be theta E equals to theta M times pole pair. If let's say we talk about omega, it must be omega E equals to omega M times pole pair. Okay? So, please don't ask me why we must do like this. Okay? Because I don't know how to question why we must do like this. I don't know how to answer why we must do like this. But I can tell you that all the things that we calculated will be used on how to help us to determine the winding layout easily. So first of all, we calculate the angle of the slot pitch. Angle of the slot. Angle of a slot. So first of all, theta S equals to 360 degree divided by number of slots. This is the 3-slot 2/4 machine. So we divide by 3. Then we have 120 mechanical degree. And then we need to convert to electrical degree. So in order to convert to electrical degree, mechanical degree times mass times pole pair. So mechanical degree times pole pair, which is NP divided by 2. So 2-pole machine, 2-pole machine divided by 2. So it's 1. Then we have 120 electrical degree. Later we will use this value. Second step, we need to calculate the angle of magnet pole. Just now, maybe I draw here. Right, what is that? Yes, Nasro.
Doktor, yang ni pun dah discuss rasanya kat video yang doktor upload tu.
Oh ya kah? Oh, terima kasih Tak, saya tutup ni pula. Then we go for next macam ni. Nasib baik you ada dengar cerita tu. Oh, thank you so much So we go for the next one. Where is it? Ini pernah cerita tak? Ni sepatut tak pernah lagi kot. This one already discussed or not? 6-slot 4-pole. Sorry.
Not yet.
Not yet. Okay, that's good. Then we continue here. So today jump very fast. Okay, first of all, how to determine 6 slot? Slot 1, 1 slot, 2 slot, 3 slot, 4 slot, 5 slot, 6 slot. So 6 slot. How many pole? 1 pole, 2 pole, 3 pole, 4 pole. So this is a 6-slot 4-pole machine. Okay, first of all, we need to know electrical to mechanical is mechanical times pole pair, where the pole pair is the number of pole divided by 2. Then we need to calculate the angle per slot. Angle per stator slot. So how to do that? Theta S is a 360 degree divided by number of slot. Then we use 360 divided by 6 because this is a 6-slot 4-pole PM machine. Then we have a 60 mechanical degree. And then we need to change to electrical degree. How to do that is we times pole pair, this one. So how many pole we have? 4 pole divided by 2. Then times it, we have 120 electrical degree. Then pole pitch is actually angle per magnet pole, per rotor pole. Angle per rotor pole. So 360 divided by NP as well. Number of pole is 4, which is 90 mechanical degree. And then we want to convert to electrical degree with times pole pair. Step 3. Find the number of slot per pole, NSPP, which is the number of slot per number of pole is 6 divided by 4. We have a 1.5, which means this is less than or equals to 1.5. And the coil we choose is 1. Number of coil means the distance per coil. the distance per coil. In order to calculate how many coil per phase we need to choose, then we need to use this formula lah, whereby 6 slot times 2 layer, which is double layer, divided by 3 phase. Then we have a 4 slot per phase, which means in this 6 slot, 4 pole machine, in order to have a 3 phase, every phases must have a 4 slot to be used, or every phases must have 2 coil. Okay, every phases. So step 5, write out the stated coil. We have a 6 slot, right? 6 slot. So it must be 1, 2, 3, 4, 5, 6. And then just copy down the MMF vector for each coil in electrical degree. Electrical degree later on. Usually MMF vector we will use F1 to represent the MMF vector. So 1 is F1, 2 is F2, 3 is F3, 4 is F4, 5 is F5, 6 is F6. Then we will start from 0. It is a must to start from 0. And then how to get the next value is actually with times. Times plus. We plus 120 electrical degree from the calculated value. This one. Okay. So we plus 120. Then we plus again become 240. Then 240 plus 120 become 360. 360 is start from 0. So 0 again. Then plus 120 plus 120. So we jot down like this. And then we need to determine the initial phase ABC. Usually A is start from 0. B is at 120. C is at 240. Actually it's I write wrongly lah. A is like this. B is like this. C is like this. Because it is 120 first and then 240. Usually we choose like this lah. And then just need to state the initial one. For example, now this is 0. This one also 0. So we cannot put double A here. We just need to start from there first. Which means phase A must have that coil of F1. Phase A must have that coil of F1. Phase B must have the coil of F2. Phase C must have the coil of F3. So after that, we need to refer the radar. So have a look on the radar. This is so-called radar. Okay. Then let me delete this one. Actually, this one is represented in the radar in the form by this theta is this line. This theta teeth 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 is this line. And then, okay, just forget about all the value here, all the writing here. Forget about it. Now, forget about it. Assume it is blank. Then we need to draw the stator line. Okay, so after we draw the circle, 1, 2, 3, 4, 5, 5 circle. Okay, then we need to draw the line. This 1 line, 2 line, 3 line, 4 line, 5 line, 6 line. Represent the teeth 1, teeth 2, teeth 3, teeth 4, teeth 5, teeth 6. After that, what is that? We need to draw the MMF vector. We need to draw the MMF vector. So MMF vector is okay. When we want to draw MMF vector, we need to refer the MMF vector row. This one. So for here, maybe it's too crowded. Let me delete it first. Okay. For here, F1 is 0. So I will draw first. F1. Maybe I zoom in. I delete this one first. Circle. I zoom in. This one first. Okay. So I will draw one arrow MMF. Then I write F1 here. It is 0 position, right? This is 0 position. Then what is that? F2 at the 120. So have a look. F2. So 120. This is 60. Then another one is 60. Hey. How much? 60, 60, 120, right? Okay. So I will draw a line. I draw a line. Then I write F2. Okay. Then F3 is 240. So F3, I draw a line again, 240, which means 60 plus 60 is 120, plus another 60, 180, plus 60 become 240. So this is F3. I draw a line and then I write F3. Next, F4 is 0. F4 is 0. So I will not redraw again. So I will just write F4 here. Huh? Which means this one got two vectors together, F1 and F4. And then F5 is 120. Huh? So I know that F5 is 120, redundant. So I just write F5 here. And then F6 240. F6 240. So F6 240 this same line as well. So I just write F6. After that, what's next? We need to list the slot number. List the slot number. Let's see. How to list the slot number. So have a look. Usually I will list the slot number 1 at here. Then this is slot 2, slot 3, 4, 5, 6 like this. So analogous to here, this is our slot 1, which is here. This is our slot 2, which is here. This is our slot 3, which is here. Slot 4, which is here. Slot 5, which means overall here is slot 5. Okay, overall here is slot 6. Overall here is a slot 1. Okay. This is just for better understanding overall. Okay, and then after we list it, then we need to state the initial phase. So have a look, where is initial phase? Phase 1 must have F1. Phase 1, I state there, must have F1. Okay. Then phase 2, phase B must have F2. So where is phase B? Phase B must have, I withdraw it, then must have F2. Okay. And then phase C must have F3. Phase 3 must have F3. Okay. Next. So after we did everything here, next we need to know how many coils we have. So that's the answer. 2 coils per phase. So we must have 1 coil, 2 coils for 1 phase. 1 coil, 2 coils for 1 phase. 1 coil, 2 coils for 1 phase. And then, because when we have a phase A, we know that phase A, we know that it must have a F1. We already decided. But the problem is we must have a 2 coil, where we say that 2 mmf lah. So currently we only have 1. So we need to combine another one. So for example, F1 plus F1 plus. So it can be F1. Let's say I delete this one. Tak nampak sangat. Okay. For example, F1, phase 1, we need to have a 2 coil or 2 mmf. So it can be F1 plus F4. It can be F1 plus F5. We cannot choose F2 because F2 already belongs to B. We also cannot choose F3 because it belongs to phase C. So we can choose F1 to F4 or F1 to F5 or F1 to F6. Okay, so the question comes here. Which one should we choose? Okay, so follow the rule of thumbs. We must choose where the angle between them, between 2 vectors, must be 0. For example, F1 is here, F4 is like this. So the angle is 0 degree. If let's say we choose F1, F5, F1, F5, the angle is 120 degrees. If let's say we choose F1 and F6, the angle is 240 degrees or negative 120 degree. Understand tak? Sampai sini boleh faham tak? Can you understand or not? How to read the angle? Masih? Understand or not?
Betul.
Okay, so the rule of thumb of rule is we must choose the distribution. The angle should be nearly to 0 because this one will contribute to kWn. As you have read, we have gone through in the basic motor sizing calculation. kWn when equal to it only varied 0 to 1. So it can give us the best efficiency or motor performance if let's say it is approaching 1. Then if let's say 0, then habis lah. So kWn, it will influence the winding distribution. The winding distribution means how can we distribute the wind? How can we coil the motor? So we can choose either option 1, either option 2, or option 3. So in here we know that option 1 gives us 0 degrees. So we will choose F1 and F4. So this one is belong to phase A. So we choose F1 and F4. F1, F4. Okay. Next, what we choose for phase B? So phase B, F2 is a must. Should we choose F2 plus F6 or F4 or not? Cannot, right? F4 already cannot be chosen because cannot be chosen because it already chosen by phase A. So only we can choose either F2 plus F5 or F2 plus F6. But for F2 plus F6, the angle will be 120 degrees. F2 and F5, it is 0 degree. So we choose F2 and F5 for phase B. So F2, F5. Next, same as well for phase C. F3, F6. F3, F6. Okay, and then come back to here. Now, when we have a F1, F4, the chosen one, we just write down, change it to become S1. For example, S4, S2, S5, 3, then 3, 6, then 6. That's it. Then after that we do some basic calculation. 1 plus 1 become 2. 4 plus 1 become 5. 2 plus 1 become 3. 5 plus 1 become 6. And then 3 plus 1 become 4. 6 plus 1 becomes 7. But 7, we need to minus 6. Why? Because we have only 6 slots. 1, 2, 3, 4, 5, 6. So 7 minus 6 become 1. Then where should we get this value? NCS. NCS is the correspond from here. Okay. Then after that we name it A. How many things? Wait. Let me finish up this one. Then we rest. Okay. So we name it A1 plus A1 minus A2 plus A2 minus. Same as well. B1 plus B1 minus B2 plus B2 minus C1 plus C1 minus C2 plus C2 minus. Okay. Then we need to put it into the winding layout. Yeah, jam. Okay, so the first coil is from S1 to S2. S1 to S2 with A1 plus, A1 minus. So where is S1? S1 here, S2 here. So A1 plus to A1 minus. Which means A1 plus here, A1 minus is here. Okay, and then 4 to 5 is 2 plus, 2 minus. 4 to 5, 2 plus, 2 minus. So this one is A2 plus, A2 minus. Boleh faham sini?
Boleh Dr.
Okay, thank you so much. So we continue. 2 to 3 is B1 plus, B1 minus. So 2 to 3, this one, 2 and 3, B1 plus, B1 minus. So this is B1 plus, this is B1 minus. And then 5 to 6, 2 plus, 2 minus. 5 to 6, 2 plus, 2 minus. So this one is a B2 plus, B2 minus. Next, 3 to 4, C1 plus, C1 minus. 3 to 4, C1 plus, C1 minus. Right? C1 plus, C1 minus. And then finally 6 to 1, C2 plus, C2 minus. 6 to 1. 6 to 1, C2 plus, C2 minus. So this is C2 plus, C2 minus. So that's it. So this is how we find the winding layout lah. Plus means go, minus means return, which means the winding can go in, then pergi belakang, then come out, then it turn again. Alright. So which means this one also one coil. This one also one coil. This one another coil for phase A lah. So in this winding, okay, for phase A, phase A, let's say this one is starting point. This one will go to A1 plus. Then this will be A1 minus. Then this must be A2, A2 plus. Then this will be A2 minus. So if we give coil, after that the line will jump to here. The line will connect to here and then coil again, then come out. So which means for phase A, it only one enter, one out, like this. This is the so-called winding layout. Okay, so yeah, we rest here. You stop here and then have a rest for 10 minutes, then we come back again 10 minutes.